Welcome to the podcast for example 1.6. Okay, well, we've been talking about rejection regions, and we've looked at a one-sided to the left and we've looked at a one-sided to the right, but we haven't yet to talk about a two-sided rejection region. So let's go over an example with a two-sided one. So just a quick definition to remind you, a rejection region is called one-sided if the set of extreme values is all in one direction, to the left or to the right. A rejection region is called two-sided if the set of extreme values are in two directions, both the left and the right. So let's take a look at an example where that happens. So here we've got bag E and bag F. Notice that bag E has this kind of sort of bell-shaped, symmetric shape to it, okay? And then we notice that bag F has kind of got this valley in it, right? Okay. And what we notice here is that the things that are more common in the alternate, as with respect comparing that to the null, are both to the left-hand side and to the right-hand side. Okay, and so when that occurs, we're going to have a two-sided or rejection region to the left or to the right. In other words, if we take a look at this particular distribution, just from a common sense sort of standpoint, if I pulled a $10 voucher, that's pretty unlikely to be out of bag E, but it's highly likely to be out of bag F. But also notice that if I pull a $1 voucher, that's not very likely to be from bag E, but it's very likely to be from bag F. So in the case of this distribution, I would reject the null hypothesis if I pulled a $10 voucher or a $1 voucher, and accept in its place that I have the alternate. But now notice I could be mistaken making that decision, because there is a $10 voucher and a $1 voucher in bag E. All right? So our job is going to be to figure out what is the chance of making a type 1 error based upon that, and also what's the chance of making a type 2 error, and then hey, while we're at it, let's go talk about the power of the test a little bit. So let's go take a look at our questions. So once again, you're allowed to select one and only one voucher from the shown bag, and you must decide whether to reject or not reject the null hypotheses. So what is the direction of extreme? Well, we just talked about that. We just said it is what? It is a two-sided direction of extreme here, okay? I'm not going to actually type that up because I think we pretty much got that dialed already, all right? So we want to develop a decision rule for the most extreme value. So what we're going to roll with our decision rule here is we're going to say what we want to do is reject the null if the voucher is less than $1 or greater than $10. Okay? Hopefully that makes sense. That's what we just said a minute ago. So that's going to be our decision rule. Okay, so now based upon that decision rule, we need to go calculate what alpha is going to be. So let's go back to the graph for a minute on the table and see if we can figure that out. Okay, so we said that our critical values were $1 and $10 respectively. So notice that what that does is it splits alpha in half. Half alpha is going to be here, and the other alpha, half alpha, is going to be over there. All right, so this is alpha over 2, and that's alpha over 2 if you want to think about it symbolically, but let's not get all crazy for the moment. Let's just come over here and take a look in the chart. So notice that the probability of pulling a $1 voucher is 1/30th. The probability of pulling a $10 voucher is 1/30th. So that gives us a combined alpha equal to what? 2/30ths, right? Well, 2/30ths is the same thing as last time I did that calculation was the same thing as 1/15th. Okay? All right, so notice if alpha is out that way, where's beta? Okay, well, to calculate beta, what we're going to do is give ourselves the same exact critical values as we had before, but notice that, well, let's think about beta for a minute. What is beta? It's the chance of rejecting the alternate when it was true. Well, notice that if I pulled, say, a $3 voucher, I'm going to say what? Well, I'm going to say it's bag E, aren't I? But if I was really holding bag F, I could have pulled a $3 voucher, couldn't I? In fact, I could have pulled a $2, $3, $4, $5, $6, all the rest of them. So calculating beta is going to be what? It's the stuff in the middle, isn't it, right? Okay, so to calculate beta, I'm going to go all the way down to, there we go, to right there, and that's where beta is going to occur, okay? We're over here, I'm going to go ahead and do it for you. That was alpha divided by 2, and that was alpha divided by 2. So let's take a look. So there's 30 vouchers total. I got 10 of them combined between the two tails, so hopefully you see real quickly there that beta is going to be equal to what? 20/30ths, right? Does that make sense? Okay. Or 20/30ths would be what? 2/3. Okay, now last but not least, they're going to ask us also to calculate what the power of the test is, so let's go ahead and do that right away. Now remember, by definition, the power of the test is 1 minus beta. In other words, that's how you calculate it. So 1 minus beta, well, that's going to be 10/30ths, isn't it, right? Because if I take 30/30ths and subtract 20/30ths from it, I get back 10/30ths, which hopefully makes a lot of sense that that's 1/3. Now, quick, just remind yourself what beta was, or 1 minus beta, the power of the test was. The power of the test was the probability of accepting the alternate when in fact it was true. In other words, it's the probability of making a correct decision when I'm holding bag F, okay? All right, so let's go fill all that in on our table over here, under the question, okay? So let's see, when we calculated alpha, what did we come up with? Let's go back and remind ourselves real quick. What did we say alpha was? That was 1/15th, okay? So how do you write down what the answer is here? Okay, well, I can say that alpha was equal to 1/15th if I wanted to, or alternately, if I was so inclined, I can turn that into a decimal. So let's get the calculator out here for just a second. Okay, and so take 1 divided by 15, and as a decimal value, that's what, 0.067, or let's come back over here to my slide here. Hang on just a sec here. I'll be right back here. There we go. Okay, so 1/15th is also equal to 0.067, or if I wanted to write that as a percentage, that's what, 6.7%. Okay, now good idea to remind yourself how to write fractions as decimals and decimals as percentages. That's going to turn out to be a real common chore in this class. Okay, so again, what was beta? Well, beta turned out to be 2/3. Okay, so if you like, you can go use your calculator to figure out what 2/3 is, but hopefully you see that as already, you know that's 0.667 for rounding out to 3 places, but what the heck, let's go ahead and do it. So that's 0.667, just like I thought it would be. So beta is going to be equal to 2/3, which is equal to 66.7%. Okay, and then the power of the test would be 1/3, which in our particular case, these are not exactly equal, they're approximates because I'm rounding off, but we'll roll with it. That's going to be 33.3%. Okay. All right. So lots of good stuff here, but the main thing I need you to make sure you carry with it is how you determine alpha and beta in a two-sided test. And to make sure that in a two-sided rejection region, big deal here that you got to pay attention to is the fact that alpha is being calculated on both sides, okay, and that beta is being calculated in the middle. Okay, well, hopefully that all makes sense. And again, I've been saying, if any of this you need additional help on, don't be shy about posting questions to the forum or sending an email.